All right, guys. Sit down. All right. So now we're gonna see how to graph these problems. Okay, we found out how to factor these, right? Could I factor this? Okay. Or actually, can you factor that?
Yeah.
What's it gonna be?
I don't know.
Okay. Okay, so let's do one that we can factor. I'm gonna change this. 5 and negative 1 won't work because 5 times negative 1 gives you a negative.
-5.
Let's change this to a 6 here. Okay. So if we were to factor this, we would have seen x plus 5 times x plus 1, right? So where would our zeros be? -5, -1, right? We figured out how to solve those, find your zeros. Okay, well we're gonna do it graphically now. Okay, so it's got to be in standard form. So ax squared plus bx plus c. Okay, so my a is gonna be what?
1.
Okay, a is 1 in front of x squared, right? B is 6, and c is 5. Okay. Now, the way we find our vertex, is this formula here. Negative b over 2a. And that's how we find the x part of our vertex. Okay, so the first thing you want to do is get it in standard form. Get your a, b, and c. And then you plug into this equation here. Okay. So b is 6. What do I always plug into?
Parentheses.
Parentheses. Okay. 6. Okay, and then a. You guys. A is 1. So it's going to be negative 6 over 2 or negative 3. Okay, so that's my x value for my vertex. So I also need a y.
Yes.
Okay, very good. So if we have the x value for our vertex, we can plug it in and solve for y. So we use this formula. Okay, so stop writing, guys. Remember, I want you following along. We use this formula to get our x value of the vertex. Okay, so this is of our vertex. Once we get the x value, we plug it back into the original equation. So we're going to say y equals negative 3 squared plus 6 times negative 3 plus 5. Give us 9 minus 18 plus 5. It's going to be negative 9 plus 5, so it's negative 4. Now, is that my vertex?
Yeah.
Okay, it is, right? So, I can graph that. Negative 3, negative 4. So, over 3, down 4. Now, is this going to open up or down? Okay, why is it opening up? Oops. Okay, because it's positive, right? The A. So if the A is positive, it will open up.
Only if the A is positive?
Only if the A is positive. If this were negative, it would open down. Okay. Now, let's see. So if we have our chart here, we'll have negative 3, negative 4. Can I pick a point to the right of my vertex?
No.
Could I say, we know it's going to look like this, right?
Yes.
Okay, it's going to come up. We don't know how, if it's going to be super thin, okay, or go slowly like that. Okay, so we need to determine what it looks like. So the way to do that is pick an x value just to the right of it. So just to the right of the -3 would be what? Okay, -2. So I'm going to put in -2 into my equation. Okay, we're going to go y equals -2 squared plus 6 times -2 plus 5. It's going to give me 4 minus 12 plus 5. It's going to give me -3. So when x is -2, y is -3. Okay. Could I get another point?
Yeah. You do the same thing.
Okay, could we do the same thing with x is -1?
Yeah.
Okay, so I'm going to enter it in. It's going to give me 1 minus 6 plus 5. It's going to give me 0. Notice, it crosses at -1, 0. Did we know that information?
Yes.
Yeah, we did from
We sure
before we knew. If we factor this, set each one equal to 0, that will be our zeros. So -1, 0. Okay, and then we have this point and that one. Now, there's something special that you're going to like about our axis of symmetry. What do we know?
It's symmetrical.
It's symmetrical, right? So, if I go...
How'd you know that?
Hey, if I go 1 point to the left, how high is my y value going to be? Will it be the same as 1 point to the right? Okay, so or one x unit to the right. It is, right? So if it's here for -2, it's going to be here for -4. So -4 is the same as -2. How about if I go one more? If I go one more over, is it going to be the same as this one there? Okay, it will be, right? So it's going to be right there. Okay. Notice. Okay, is -5, 0, is that an expected point?
Yes.
It is, right? Because if we factored it, set that equal to 0, we get that. Okay, so here's our answer. Okay, and it seems like a lot of computation. There's a fair amount. What you start at is get your A, B, and C, plug it into this equation for your vertex. Once you get the x, you plug it back in. Once you have your vertex, you choose a point to the right of it. Then choose another one even further to the right. Okay, those will give you 2 more points, and then you can reflect them about your axis of symmetry. Okay? Alright, I know it seems like a lot. We're going to do a few of them here, so go ahead and do 2B.
Okay.
So what are your answers?